Hello, so in today's class, let us look at the expression for the code of conduct in polar form. Now, by code of conduct, you mean that is the chord joining the points of contacts of tangents which are drawn to a conic from a point which is lying outside the conic. So, we have a point which is not on the conic. So, from that point, there will be a pair of tangents. So, pair of tangents will be touching your conic at 2 points. So, join those 2 points. That will give the chord of contact. So, that's the definition for the chord of contact. So, it is a chord joining the points of contact of tangents to a conic from a given point outside the conic. So let us look at what will be the equation of the chord of contact. So first let us consider the equation of the conic and let us take a point which is not lying on the conic from which the tangents are drawn. So let L by R equal to 1 minus E cos theta be the equation of the conic. And we have a point r1 theta 1. So r1 theta 1 be the point from which the tangents are drawn to the conic. And let us take the vectorial angles to be alpha minus beta and alpha plus beta. So we have seen the equation of the chord joining when the vectorial angles are of the form alpha minus beta and alpha plus beta. So we will use that equation to represent the chord. So let alpha minus beta and alpha plus beta be the vectorial angles of the 2 points of contact of the tangents. Then, as we have seen in the previous class, so then the equation of chord joining them will be given by so that will be L by R equal to minus E cos theta plus you'll get sec beta into cos theta minus alpha. Now we have also seen the equation of the tangents where the vectorials are theta minus alpha minus beta and alpha plus beta. We know that these tangents are going to pass through the point r1 theta 1. So this will give us the equation of the chord in terms of the coordinate r1 theta 1. So let us write the expression for the equation of tangents also. So the equation of tangents at the point on the conic having vectorial angles alpha minus beta and alpha plus beta is given by, so that will be L by R equal to minus E cos theta plus cos theta minus alpha plus beta varum, and L by R equal to minus E cos theta plus cos theta minus alpha minus beta. Now, since these lines pass through R1 theta 1, so it will the equation is satisfied when you substitute R1 theta 1. So we will get, so substitute, so replace R by R1 and theta by theta 1. So we will get L by R1 equal to minus E cos theta 1 plus cos theta 1 minus alpha plus beta varum, and L by R1 equal to minus E cos theta 1 plus cos theta 1 minus alpha minus beta. Now we have L by R1 and minus E cos theta 1. So that is same in both the equations. ഈ രണ്ട് ടേംസും സെയിം ആണ്. സോ therefore that will give cos theta 1 minus alpha plus beta equal to cos theta 1 minus alpha minus beta. So therefore from these two equations we are getting cos theta 1 minus alpha plus beta, that will be equal to cos theta 1 minus alpha minus beta. And now for this to be equal, so this will be possible, so that implies theta 1 minus alpha plus beta, so the angles must be equal. Angles ഒന്നെങ്കിൽ equal ആയിരിക്കണം, അല്ലെങ്കിൽ, so if you have cos A equal to cos B, then A will be equal to plus or minus B. So therefore we will get plus or minus theta 1 minus alpha minus beta, and again since beta is not equal to 0, if you are taking theta 1 minus alpha plus beta equal to theta 1 minus alpha, so if I am taking the plus sign here, so what happens here is രണ്ട് സൈഡിലും theta 1 ഉം minus alpha and cancel ആവും, so remaining we are getting 2 beta equal to 0, but beta cannot be equal to 0, so since beta is not equal to 0, we will get theta 1 minus alpha plus beta, this must be equal to minus theta 1 minus alpha minus beta. So that gives 2 theta 1 equal to, so we are going to get 2 alpha, so therefore we will have alpha equal to theta 1. So now let us substitute alpha equal to theta 1 into the equation. So therefore L by, so the equation of first tangent will be L by R1 equal to minus E cos theta 1 plus beta varum. So theta will be equal to theta 1 and alpha will be equal to theta 1. So that will give L by R1 equal to minus E cos theta 1 plus cos theta. So this is the equation we obtain when we substitute the given value of alpha into this equation. To substitute theta 1 equal to alpha in the equation of the chord, so that is going to give L by R equal to minus E cos theta plus theta cos theta minus theta 1. So that will give L by R plus E cos theta equal to cos theta minus theta 1 by cos theta minus 1. So that will be L by R plus E cos theta into, now this is cos theta equal to cos theta minus theta 1. So we will get L by R plus E cos theta into, now from this equation cos theta will be L by R1 plus E cos theta 1. So we will get L by R plus E cos theta into L by R1 plus E cos theta 1 equal to cos theta minus theta 1. So this is the equation of the chord of contact to the points R1, theta 1. So therefore this is the equation of the chord of contact of tangents to the point R1 theta. We started with the equation of conic as L by R equal to 1 minus E cos theta, and again the equation of conic can be in the form L by R equal to 1 plus E cos theta. So in that case, in the final equation, so we will have a minus sign in these two. So you have the equation of conic to be L by R equal to 1 plus E cos theta, then the equation of the chord will be L by R equal to L by R plus minus E cos theta, L by R1 minus E cos theta 1 equal to cos theta minus theta 1. So, and that is write it as a note. So, if the equation of the conic is L by R equal to 1 plus E cos theta, then the equation of the chord of contact of the tangents to the conic from the point R1 theta 1 is given by, so that is going to be L by R minus E cos theta into L by R1 minus E cos theta 1, that will be equal to cos theta minus theta 1. So that is going to be the equation of the chord of contact when conic is in the form L by R equal to 1 plus E cos theta.